Hi guys, welcome to my channel. In this video we are going to solve a questions about the structure analysis. The question will be solved due to Cantilever method, and so let's solve the question. Before everything, now I am going to calculate the centroid of the structure. So it's going to be x bar equal to a multiplied this length, a the area of this column. You can see this cross sectional are the same, multiplied 18 plus a multiplied 38 over 3a is equal to 18.667 feet. Okay, so now I just sketched this to here to understand, so to try to make it better. So this point from that to that point is 18.667. okay, and this is 18, and here is 6.667, and this is 19 point, I guess, 333, this length. So now first I'm going to take a moment. I'm going to have a cut here, from these inflection points, and I will take the cut here. Now you can see I have a force here, and also here, because now you can see if the left part of the centroid is going to be downward direction, the right part of the centroid is going to be upward direction. So I write this force as upward direction. Okay, and this point also will be J, L, and O. Okay. And this is how we show the forces. Okay, the force will be downward direction for here. This is E, so I, and this is J, and this is H, this is G, this is L, and this is O. These are the points and the forces. Sorry, this will be upward direction. I made a mistake. This will be upward direction. And the forces will be at this way. So let's write a moment at J, respect to J. We have a 3 kilonewton force, 3 kips per year as a force. So let's write the moment respect to J at this direction, positive. And this is H, this is G. So minus 3 multiplied 7.5, because this is 15 and this is 7.5 as the length, and minus HL, this is HL, multiplied 18, and plus OG multiplied 38 equal to 0. Now you can see we have one unknown and we have two unknown and one equation, so we cannot solve this one. So we are going to solve this question due to the stresses. Okay, these are stresses, and these are all the stresses. Now I'm going to write here, these are all stresses. This length now you can see 0.667, this length 19.333, and this length 18 also, from here to that point. So we are going to use the triangular and try to define these stresses and the forces. Okay, so let's write it. The sigma HL over sigma OG, sigma HL over sigma OG will be equal to this length over this length. Okay, 0.667. I guess you remember from the similarity in the geometry, 19.333. so OG will be equal to sigma HL multiplied 19.333 over 0.667. Okay, now we have OG in terms of HL. So when I write this one into this equation, let's write it here. minus 3 multiplied 7.5 and minus HL multiplied 18, I'm sorry, and HL multiplied 19.333 multiplied 38 over 0.667 equal to 0, and HL will be equal to 0.0276 kips. Now this is the HL force, the force of HL as a y direction, okay? When I write this one into the equations, and I'm going to obtain OG, when I write this into this equation, I'm going to obtain OG. What is OG? OG also 0.6019 kips, and IJ equal to 0.5812 kips. Now we obtain this all, now you can see. So let's solve this part, because we are going to determine the reactions at A. So we are just going to deal with this part, okay? So let's solve this part, this L. And now I just write it automatically IJ, but IJ is going to be actually the same, something like that. When you divide this length, sigma IJ over sigma GO, and you're going to divide to this length, okay? From that, you're going to obtain also IJ, because you know OG, when you write OG, you're going to obtain IJ. So let's solve this part. I have a force here as IJ, okay? A J Y 0.5812. I have a JX, and I have a 3 kips here, and I'm going to have a upward force as here, because there is no any other vertical force, so this will also be 0.5812, and I will have a KX. So now let's write the total Fy. Actually, I don't need to write the total Fy, because you know, if this is 0.5812, so it's going to be the same, because there is no any other vertical force. So let's write the total moment here, total moment at J equal to 0. So it's going to be minus 3 multiplied 7.5 and plus 0.5812 multiplied 9 and plus kx multiplied 7.5. So kx will be equal to 2.303 kips. Now we have this one. So let's write the total fx and determine the jx also. And for jx, 3 minus 2.303 minus jx equal to 0. And so jx will be equal to 0.6974k. Now also we have jx. So let's to solve this part, but to solve this t part, we have to first to determine these forces. Sorry, this downward and downward forces. Let's check them. Yeah, now we are going to solve this one. I'm going to do this like the same before. Okay, so this will be I, H, G, and let's check other for letters, D, E, F, D, E, and F, and this is R, S, and T. Okay, so actually, like I said, like I told you before, we are going to show the forces, which one is upward, which one is downward direction. Okay, this will be upward direction, these are the downward direction, and these are the stresses. For example, dr, this is the ES, and this is the ft. Okay, so let's write the same equation. So the same, I'm going to take the moment actually respect to that point. Okay, I have a force here as 4 and force here 3, and now that's okay, I guess. So let's take the moment, total moment at r is equal to 0 and minus 3 multiplied 22.5, because this is 15 feet, this is 7.5 feet, so this is 22.5. Okay, I actually cut from the half of this. Yeah, these inflection points, because the inflection points has to be at the midpoint of beams and columns. And I have a 4 here as a force, minus 4 multiplied 7.5, and minus E, look at here, this will be at this direction, this will be at this direction, this will be at this direction, like here you can see. So this will rotate at this direction. We are going to write as ES multiplied with 18 and plus TF, this one will be multiplied by 38 equal to 0. Now we have one equation, you can see, but we have two unknowns. So we have to determine something to solve this equation and determine the forces. So we are going to use this one. Okay, this length again the same, because there is no any change for here, and this is feet, 18 feet. So we are going to make, how can I say, we are going to have a ratio from these stresses, now you can see, and from that ratio we are going to obtain the forces like before I did. So sigma ES over sigma FT, it's going to be equal to this length over this length. Okay, this length over this length, 19.333. So from here we are going to obtain sigma ft, so tf or ft, this is okay, it's the same, tf or ft equal to 19.333 multiplied sigma es over, I have a here force, so the length as 0667. Okay, now we write this tf in terms of es. So when I write in this equation, when I write this one into this equation, I'm going to obtain just one unknown and one equation. So it's okay, it's going to be easy to solve it. Let's solve it. I'm going to rewrite the moment equation here. This is equal to 0. And from here, ES will be equal to, so it's like that, ES will be equal to 0.09K, and TF or FT, it doesn't matter, TF will be equal to 2.603 kips. And when I want to calculate the DR, so this is DR actually, when I want to calculate DR, I'm going to make a comparison like this again, make a ratio. This is going to be, for example, DR, sigma DR over sigma FT. This length, what is this length? It is 18.333 18.667, and over sigma ft, what is the length? 19.333. and write like this, dr, sorry, it's going to be sigma ft multiplied 18.667 over 19.333. Now from this, I'm gonna, when I write this value into this equation, so sigma dr will be equal to 2.518 kips. Okay, now we obtain all forces, so let's solve this part also. Okay, this part, this t, from here to that to this point. Okay, this t. For this t, I have forces from the up part. This force jy and jx. So what is jy? Let's check. O point jy. It's going to be this direction, 0.5812, because in the previous it was a downward direction, so now it's going to be upward direction. So for this one, for example, it's going to be from left to right. So it's going to be jx 0.6974. Okay, 6974. I have now here force. What is the force of here? 2.518, right? And also we have forces here, we have forces here, and we have forces here. I have here as a 4 kips. Now I guess it is okay, so let's solve this part. This is going to be point px, this is going to be py, and rx. So the total fy is equal to 0, 0.5812 plus py minus 2.518. This will be equal to 0, and py will be equal to 1937 kips. So let's take the moment mr respect to point r, and this side is positive, minus 4 multiplied 7.5 and minus 0.6974 multiplied 15 plus 1.937 multiplied 9. Okay, this is because this is py. Here it's going to rotate at this direction, py. And also we are going to take plus, px. What is px? We don't know. We are going to obtain it. 7.5 equal to 0. Now one unknown and one equation, so px equal to 3.07 kips. Now we also obtain the px. Let's write the total fx equal to 0. 4 minus 3.07 plus 0.6974 and minus rx equal to 0, and rx and here rx equal to 1.627 kips. So now this part is also okay. Let's solve the last part. Yeah, this last part. And this will be actually 7.5 feet as length. And this is the y force will be 2.518 at this direction. This is rx. If it is this direction, for this part, it's going to be at this direction. Yeah, it has to be also always reverse. Okay, and for this one, 1.627 and 2.518 kips. So now we have all forces for here. And now the question is solved actually, but let's determine the moment here. The moment will be created. 2.518 multiplied 7.5, and this will be equal to, I guess, 17.2 cubes to feet. Sorry. Now the question is solved. Thank you for watching. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did something wrong, please comment. I'm trying to do the best. See you for the next question.